The next thing we're going to do is find products of linear factors with given zeros. We have done this a little bit. So if you think about the fact that in the previous lesson, when we had a zero of -4, we wrote that as a linear factor x plus 4. And so that skill's going to stay, but we're going to kind of make, not going to kind of, we are going to make the zeros a little more complicated and talk about what the factors would look like. So just a little discussion before we do it. There's two ways of thinking about how to end up as your linear factor from your zero. Way number one is that you always end up with a product of linear factors that are in the form x minus c. So if you look at this first example, if we were to write this as x minus, this is the c value. We're putting in -4, which makes your factor x plus 4. So that's one way of thinking about it. The other way of thinking about it is that when you have a zero of x equals -4, the zero makes it equal to 0. So if I was to add 4 to each side, I end up with x plus 4 is equal to 0, and x plus 4 is the linear factor. Now I say this because now we're going to get to this question. And I had to create a worksheet because the textbook and I had a little bit of a discrepancy, and I think I'm right. I also feel like they're right. But for what we're going to do, I think what I'm going to show you is more standard, kind of more what's used across the board. So when you have a zero like -1/2, if you were to plug -1/2 in for c, you would end up with x minus -1/2, and your zero would be x plus a half. But what you're going to notice is that when we multiply polynomial functions together, you never end up with fractions. Now you can, but none of the ones that we do will. And here's where the discrepancy comes into play, is that if you use synthetic division, you would use the zero of -1/2, you would put your factor like this, and then there'd be some magic that would happen that you would end up with a 2 out front, that when you multiply it through, you would end up with 2x plus 1. But only with synthetic division. If you do long division, you would actually have to put the factor as 2x plus 1 to start. Now, this is all the verbal dialogue that's going into my head. You don't need to know this. But what I will say is that we're not going to write the factors as x plus a half. We're going to write it as 2x plus 1. So if you end up using this x minus c thing where you put in -1/2 and it becomes x plus a half, just know that this 2 is always going to come up in front of the x, and it's going to be because a 2 will come out of the polynomial and it'll multiply through. But for us, just know that this is what we're going to end up with, which is why I prefer the x equals -1/2 root, right? That's my 0. And then I'm going to multiply by 2 first, and then I'm going to bring that plus 1, and I end up with my factor being 2x plus 1. So for this one, my factor will be 2x plus 1, and for this one, my factor will be x plus 4. Okay. What if my x was, or what if my 0 was a 0? So if I use the x minus c thing, I'd have x minus 0. Well, it's just an x. Even if I started with x equals 0, it's just an x. So if you ever have a 0 as a 0, know that there will be an x in your factored polynomial function. All right. Whew. What about 2/3? So how the heck am I going to write 2/3 as a linear factor? Well, I gave you one option. You've got x minus 2/3, and then you have to know that that 3 is always going to come up, right? So it's going to come up because of 3. If you use synthetic division, a 3 will come out and multiply through, but this is the linear factor I'm looking for. Or if you had something like x is equal to 2/3, you would multiply both sides by 3. Then you'd bring the 2 over and you end up with 3x minus 2 equals 0. That's the original factor. And so then we end up with 3x minus 2. If we have x equals 3, no matter what method you choose, your factor is going to be x minus 3. And now we get to move on to the more complicated zeros, which is going to be we're going to kind of transition into in this chapter. So the next 4 zeros that I have a root 3, I have a negative 5i, I have a 1 plus 2i, and I have a 1 minus root 6. And these are going to be kind of what the next topic coming up is going to be, is these irrational or imaginary zeros. But you do the process the same. So just like if your 0 was 3, this is going to be x minus root 3. Whether you get there by saying, hey, it's x minus c, I'm going to put in my value of c, or whether you say, hey, if x equals negative or x equals root 3, I'm going to subtract root 3 and have my factor. Whatever works in your head. Same thing with this one. This one's going to be x plus 5i. So it's x minus 5i, or if x equals negative 5i, you're going to add 5 to the other side. Then we get into these ones. Now these are going to be the solutions we get when we come down to a quadratic that we have to solve by either the quadratic formula or completing the square. So we get these, 1 plus 2i or 1 minus 2i, and then 1 minus root 6 or 1 plus root 6. Now again, you can do it the same way. You have two choices. You can put it in as x minus the 1 plus 2i, which would give you a factor of x minus 1 minus 2i. Or you can say, hey, if x equals 1 plus 2i, my factor would be x minus 1 minus 2i. I have to take them over to the other side. And again, that's the same factor. All right, pause the video, give this one a go. What do you get as your factor? So I'm going to get x minus 1 plus root 6. And again, whether you put it in as x minus 1 minus root 6, or if you say if x equals this and then bring everything to the other side, doesn't matter to me. Then what we're going to transition into is writing zeros as a product of linear factors. So instead of just having a 0, we're going to have multiple zeros, and we're just going to write them as a product of what the linear factors would look like. So if I have 1, 2, 3, 4, 5 zeros, that means that my function is going to have 1, 2, 3, 4, 5 brackets. And we got to figure out what's going to go in the brackets. So again, you can treat them as x equals and then bring everything over, or you can go x minus 4, x minus 0. I've got that x minus 1/3. I've got that x minus root 2, and I've got an x plus root 2. And then we're going to fix this. So the first thing I'm going to fix is the fact that we've got this x minus 0. That's going to end up as just an x, and I'm always going to write it first. So now I've got x times x plus 4. Then I'm going to fix this one. If you wrote it this way, maybe you didn't, maybe you jumped straight to 3x minus 1, but that's what we're going to be looking for in this section. And then we have x minus root 2, and we have x plus root 2. That's it. Okay, so why don't you pause the video and give this one a go. All right, so what would I get? My first factor would be x minus 3. My next one would be x minus 1 minus 2i. And then lastly, x minus 1 plus 2i. And whichever method you use to get there, this is the answer you should get. If you're confused about this, please come and ask me. Send me an email, set up a Zoom time, or come into the upgrading room and anyone will help explain it to you. And then the last one is, how else can they ask you the question? Well, they can say specifically that we're going to end up with a degree 5, and they can give you different zeros with different multiplicities. So up until now, the degrees just kind of happened. This would be a degree 1, 2, 3, 4, 5. This would be a degree 1, 2, 3. So however many factors you have, that's the degree of your polynomial. So for this one, when they're telling you these multiplicities, what that means is that you have a 0 of negative 1, so my factor would be x plus 1, and then because it has a multiplicity of 3, you're just going to cube it, right? Because the x plus 1 would appear 3 times. Then we have 4 with a multiplicity of 1, so that's going to be x minus 4. And then lastly, we have a 0 of 0 with a multiplicity of 1. Now I always like to throw those out front. And that would be my answer. And if I counted up my x's, I have 1, 2, 3, 4, 5. So it's a 5th degree polynomial. Awesome. Go and practice that.